Hi, I'm Linda from English Learning Mind Map. Today, we will learn about automotive engineering. Automotive engineering. To advance mobility and optimize performance through automotive engineering, designers focus on the harmony between power and safety. Basically, we are making cars that are faster, smarter, and much safer to drive. Propulsion systems. As a core pillar of automotive engineering, propulsion systems allow a vehicle to generate torque and maximize efficiency on the highway. In simple terms, this is the engine or motor that makes the car go. Energy storage. Energy storage is a vital part of propulsion systems used to retain charge and prolong range for long journeys. This means we are finding better ways to carry electricity or fuel so you don't have to stop so often. Electrolytic density. Through better electrolytic density, energy storage can pack power and lighten weight for modern electric cars. To put it simply, we are making batteries that hold more energy but aren't as heavy as a piano. Thermal management. A key branch of propulsion systems is thermal management, which is used to dissipate heat and prevent overheating during fast driving. Essentially, we are keeping the engine at the perfect temperature so it doesn't get too hot. Coolant regulation. Within the scope of thermal management, coolant regulation works to circulate fluid and maintain balance inside the motor. In other words, we are pumping liquid through the engine to carry away the heat. Chassis dynamics. Chassis dynamics is a functional layer of automotive engineering designed to improve handling and stabilize motion on curvy roads. Basically, we are making sure the car stays flat and steady when you turn a corner. Suspension geometry. Suspension geometry is a technical branch of chassis dynamics used to absorb impact and align wheels for a smooth ride. This means we are arranging the metal arms and springs so the wheels always touch the road correctly. Adaptive damping. Under the umbrella of suspension geometry, adaptive damping helps to soften bumps and stiffen ride quality automatically. Simply put, the car shocks change their hardness instantly to match the road surface. Traction control. Traction control is an essential part of chassis dynamics used to prevent slippage and ensure grip on wet or icy streets. In short, the car's computer stops the wheels from spinning out when the road is slippery. Torque vectoring. As a specialized feature of traction control, torque vectoring can shift power and sharpen turns by helping the wheels spin at different speeds. To put it simply, the car pushes harder on the outside wheel to help you turn better. Safety architecture. Safety architecture is a critical requirement of automotive engineering to protect occupants and withstand collisions in an accident. Effectively, we are building a strong cage around the passengers to keep them safe. Structural integrity. Structural integrity is a foundational layer of safety architecture used to reinforce frames and absorb kinetic energy during a crash. In other words, we are making the skeleton of the car strong enough to stay in one piece. Crumple zones. Within the scope of structural integrity, crumple zones are designed to fold metal and divert force away from the people inside. Basically, the front of the car is made to squash like a tin can so you don't feel the hit. Passive restraints. Passive restraints are a functional branch of safety architecture used to cushion impact and limit movement for everyone in the car. This includes things like seat belts that hold you in place automatically. Airbag deployment. Airbag deployment is a life-saving part of passive restraints that works to inflate rapidly and prevent trauma in milliseconds. To put it simply, a soft pillow pops out instantly to stop your head from hitting something hard. Autonomous integration. Autonomous integration is an advanced branch of automotive engineering used to remove error and automate navigation without a driver. Essentially, we are building cars that can see and drive all by themselves. Sensor fusion. Sensor fusion is a vital aspect of autonomous integration used to interpret surroundings and synthesize data from many cameras. This means the car looks at everything at once to understand where it is. LiDAR mapping. A key tool for sensor fusion is LiDAR mapping, which works to bounce lasers and detect obstacles in 3D. In short, The car sends out tiny light beams to see exactly how far away every tree and person is. Edge computing. Edge computing is a high-tech layer of autonomous integration used to process locally and react instantly to road hazards. This means the car has a super-fast computer inside, so it doesn't have to wait for the internet to think. Latency reduction. By achieving significant latency reduction, edge computing helps to speed thinking and save lives during emergency maneuvers. To put it simply, we are making the car's brain react in a tiny fraction of a second. Thanks for watching. Please like and subscribe for more English lessons.